Hi everyone and welcome. This is the group number three. And in this video, we'll go through questionnaires and surveys analysis with R. This tutorial is an introductory guide to creating surveys and questionnaires, visualizing their data and analyzing it. It is aiming to beginners and intermediate users of R and focuses on showcasing useful methods, survey data analysis.
First thing that we have to do is to install the tools that we're going to use in this tutorial. We have to install R and RStudio. Here in this website we have these two files that we're going to use it, and these steps is basically to download the two files, put it in the same folder, create a new file, open it, and you have to press here surveys, and you have here the code. This is the code that we're going to use for the tutorial. So we have to start first with some theory about the surveys and questionnaires. So let's start with the tutorial first, and then my partners will start with the explanation of the code.
Okay, about the theory, we'll start with what is a survey. A survey is a research method used to gather information from a sample of people. And the questionnaire is the tool that we use to get that information. From the questionnaire, we can get three types of data. We can get factual data, behavioral data, and attitudinal data. The factual data relates to what a respondent is or does, while behavioral data focuses on the actions. And attitudinal data relates to what the respondent thinks or feels. About the advantages and the disadvantages, we could say that surveys are cost effective. They are quick and reach a large number of people. But we can get unreliable information because people use to give information that they think that is socially acceptable rather than their true feelings. When designing a questionnaire, there are some important rules that we need to follow. For example, surveys should be long enough to get all the necessary data, but not in an excessive way. It is crucial that the questionnaire get the information we need. The language must be simple and clear, so we have to avoid jargon or leading questions that may introduce bias. The questionnaire must be pilot, so we can ensure that the questions are easy to understand and everybody can understand what we're asking for. The question must be clear, and we have to avoid to ask multiple things at once. For example, instead of asking, do you consider UQ to be a good university in terms of teaching and research? We have to split it into two questions, one question for research and one question for teaching. When offering multiple choice option, make sure that the scale is fine-grained enough to capture the nuances of the data. There are different scales of data. For example, we have nominal and categorical. Nominal scale gives you only two options. For example, yes, no, or on, off. While categorical scales give you several options. For example, the state where you were born. Your country can have multiple states, so you have several options in this case. Ordinal scales. With ordinal scales, it is possible to run the values, but the distances between the values cannot be quantified. For example, in a 100 meters run, the number 2 didn't go twice as fast as the number 4. Numerical scales. We have two basic types of numerical scales. We have interval scales and rate scales. For interval scales, the difference between levels are significant, but not the relationship between levels. For example, 20 degrees is not twice as hot as 10 degrees. For that scales, both the difference and the relationship between the levels are significant. For example, in a 100-meter dash, 10 is exactly twice as high and half as much as 20.
Visualizing survey data. When we have multiple data of a survey, we can graphicate with three types of graphics, like line graph for Likert scaled data, pie charts, and bar plots. For these graphics, we need to install all this package, and when finally we need to a dates, a table of dates. With this code, we can generate that. In this case, we have the L data for the first graphic, line graphs, and it's like this: course, Chinese, 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 and all these the data, and all a small in level of satisfaction. And with this table, we can graphicate the line graphs like this: course, Chinese, German, Japanese, and the graphic. Of course, we can graphicate this with a pie chart like this. Mhm. We generate other table of data called name B data with satisfaction, frequency, and percent. Percent is important for the tag of the pie charts, and we can generate that with this code. Create pie charts like this. We have satisfaction, very decisive, neutral, satisfied, and very satisfied, and the tag. Of course, we can graphicate this table in a bar plot like this. It's more it's more entendible, but we can measure it with groups like this. We add some information for the data, for the table of data, and we create with this code like this. And we have the level of satisfaction, the frequency, and the course: Chinese, German, and Japanese. And if we need some specific graphic of bar plots, we can organize the most beautiful way, like this code. We have someone different scores like Chinese, German, and Japanese, and we can all of them we can separate of the level of satisfaction of depends of the course, like this graphic. In this way, we have the course Chinese, German, Japanese, the frequency, and the satisfaction with with a most entendible graphic. Thank you.
Okay. Um, we will we we will focus on case statistical techniques and their importance in ensuring the reliability and validity of survey results. First, talk about Cambridge Alpha. This is tactic measures the internal consistent of survey agents with multiple questions aimed to assess the same concept. We expect their response to correlate. Imagine that you conduct a survey to assess job satisfaction with the following questions: are you satisfied with your current job role? Are you feeling valued by your team? Are you recommended this company as a great place to work? With multiple questions aimed to assess the same conception like job satisfaction, we expect the response to correlate. For with their job role, they are like to also feel valued by your team. By calculating Cronbush alpha for these four teams, we can determine if the variable measure that the underlying construct of job satisfaction. A Cronbush alpha is a value about 0.7, typically indicates good internal consistency, suggesting that the questions are effectively capturing the same concept. A value alpha below 0 point 7 suggests that the question may not be reliable. This is crucial for ensuring that our construes are validation and essential foundation for any statistical analysis. Yeah, wait a minute. Sorry. Um, while Cambridge Alpha static analysis is widely used, it has limitations. So we have so many alternatives. Um, one of these alternatives is Omega. Um, these alternatives are vital for researchers seeking a deeper understanding of their data relatively. Using R, we can easily calculate a Cronbach alpha using the package. This capability is significant because R efficiently handles large datasets, enabling quick reliability assessments across diverse populations. Next, uh, we run the code to calculate omega. In this code, we can see these dots. Wait a minute, please. Okay. Okay. Let me. Okay, sorry. This is our values, result values. So we have value above 0.7. So we have questions if it's because during the same concept. Okay. So in the omega, we have so many forms to using in using Kaggle Omega in the air, but we have to uh, shows how we calculate Omega the manually way. You can see how we have the value. The value is 0.9, so indicate the same thing that we our questions are related with the topic. Okay, next, we have factor analysis. This technique identifies common factor among related variables, simplifying complex data sets. In R, we can use the factorial function to perform factor analysis, helping use visualize how questions group together. This is essential for understanding the underlying structure of the data. When we analyze the response to these questions, we might notice that some questions are highly correlated. For instance, questions about motivation and feedback by closer together, indicating that they are sharing common underlying factor. Factor analysis is crucial for data reduction, allowing research to simplify their models while retaining essential information. Um, Errors visualization's capabilities make interpreting these results straightforward, moving on to principal components analysis or PCA. This method reduces data dimensionality by combining several variables into a single component, which is especially useful when multiplication reflects a common factor. In R, we can perform a principal component analysis using the printcop function, helping us identify key components that explain the majority of variance in our data. Wait with me, in this code, we can see the principal components and this. R allows the seamless execution and effective visualization, making it easy to communicate key findings.
Ordinal regression is very similar to multiple linear regression, but takes an ordinal variable as a dependent variable. So in order to implement in R this ordinal regression, we are gonna load the ordinal dataset. The dataset consists of 400 observations of students that were either each educated at this school, internal equals 1, or not, internal equals 0. Some of those students have been abroad, exchange equals 1, or have not, exchange equals 0. In addition, this dataset contains the final score for a language test, and the dependent variable, which is the recommendation of a committee for an additional very prestigious program. The recommendation has three levels that we can see here: unlikely, somewhat likely, very likely. We are gonna reveal that data group for those categories, and we're gonna show a table of frequencies right here. Now, as the final score is a numerical variable, so we're gonna summarize that with the mean and the standard deviation. We got the value of 1.9 of in the mean and the max of 4, the median of almost 3. We're gonna visualize the data on a plot right here, and we are gonna interpret the results. So as we can see, this plot, we have the recommend variable on the x-axis and the final score on y. We have external, internal against exchange and not exchange variables. And the three levels of are ordinal variable. So we see that we have very few observations in external and internal and all. And the observations of the very likely recommendation is very low also. Another thing we can say is that the prediction could be that the most likely to have a very likely recommendation is this variable, this internal student. We are gonna confirm that running some tests as in this part. So have to calculate the p-values. So we transform t-value into a p-value. This value here, this internal variable, that is lower, a lot lower than the 5% of alpha. So this means that this variable has a very significant impact on the dependent variable, that is the recommendation variable. Now we are profiling, and we have this table on a more structured manner. So we see all the variables and then the probability. Finally, we are gonna plot this data in a more explicative and graphic way in order to analyze the the happening. We can see that we have in this part the final score in the x-axis and the probability on y. So we see that the tendencies are unlikely, is dropping down. Its probability against the final scores, external against exchange, external against exchange, and so on. Somewhat likely, it's growing in all cases, and very likely has a very low probability that it's increasing in all cases, but it's very low. So that confirms that the graphics and the calculus are all coherent. And we see that this kind of methods helps a lot on analyzing and validating um, data sets that has to deal with surveys and this kind of research methods. That is all for this presentation. That is the website that we gather all the information. And thank you very much.